Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're continuing our deep dive into Kafka consumers. In our previous episode, we covered consumer groups and offsets. Now we're moving on to a crucial aspect of Kafka consumers: configurations and performance tuning. Joining me as always is our Kafka expert, Victor. Hey Victor, ready to tune up some consumers?
Hey Sheila. Absolutely, I'm excited to dive into this topic. Configuring and tuning Kafka consumers is like fine-tuning a high-performance engine. Get it right, and you'll see amazing results.
That's a great analogy, Victor. Before we start, I'd like to pose a quiz question to our listeners. Here it is. What is consumer lag, and why is it important when tuning Kafka consumer performance? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of consumer performance. I'm curious to see how our listeners will approach this. It's not just about defining consumer lag, but understanding its implications for the entire Kafka ecosystem. Let's keep our listeners in suspense and dive into our main topic.
Absolutely. So, Victor, let's start with the basics. What are some of the key configurations we need to consider when setting up a Kafka consumer?
Great question, Sheila. There are several important configurations, but let's start with two fundamental ones: fetch.min.bytes and fetch.max.bytes. These parameters control how much data a consumer fetches in each request to the Kafka broker, which is like a message storage and distribution center.
Interesting. So, it's like deciding how big of a plate you want at a buffet. Can you explain how these configurations affect performance?
That's a perfect analogy, Sheila. Exactly like a buffet, if you set fetch.min.bytes too low, you might make many trips for small amounts of food. This can increase network overhead. On the other hand, if you set fetch.max.bytes too high, you might overflow your plate or spend too much time filling it up.
I see. So it's all about finding the right balance. What about the speed at which we consume messages? Is there a configuration for that?
Indeed there is. The max_poll.records configuration controls the maximum number of records returned in a single call to poll. It's like deciding how many items you'll pick up each time you visit the buffet.
That makes sense. Now I've heard about something called session timeout. How does that come into play with consumer configurations?
Great question. The session.timeout.ms and heartbeat.interval.ms configurations are crucial for maintaining the consumer's membership in a consumer group. If a consumer fails to send heartbeats to the group coordinator within the session timeout, it's considered inactive and a rebalance is triggered.
Wow, that sounds important. So it's like the buffet manager checking if you're still at your table, and if you don't respond, they might give your spot to someone else.
Exactly. And just like in a busy restaurant, you want to set these values carefully. If the timeout is too short, you might trigger unnecessary rebalances. If it's too long, it might take a while to detect inactive consumers.
I can see how that could impact performance. What about handling errors or crashes? Are there configurations for that?
Absolutely. The auto.offset.reset configuration is crucial here. It determines what happens when a consumer starts reading from a topic and there's no saved position, or the saved position is invalid. You can set it to earliest to start from the beginning of the topic, or latest to start from the end.
That's interesting. It reminds me of bookmarking a page in a book. If you lose your bookmark, you need to decide whether to start from the beginning or just continue from the end. Are there any other configurations related to keeping track of our reading position?
Great analogy, Sheila. Yes, there are two more important configurations related to this: enable.auto.commit and auto.commit.interval.ms. These control whether and how often the consumer automatically saves its position in the topic.
I see. So, automatic commit is like the bookmark, automatically updating as you read. How does this affect performance?
Exactly. While auto-commit is convenient, it can impact performance and message delivery guarantees. If set too frequently, it can create unnecessary network traffic. If set too infrequently, you risk reprocessing more messages in case of a failure.
This is fascinating, Victor. It seems like there's a lot to balance when configuring Kafka consumers. How does this compare to configuring consumers in other messaging systems like RabbitMQ?
That's a great question, Sheila. While both Kafka and RabbitMQ are messaging systems, they have different architectures which affect how consumers are configured. RabbitMQ actively sends messages to consumers, while Kafka lets consumers request messages. This fundamental difference means that in RabbitMQ, you're often configuring things like prefetch count, which is somewhat similar to Kafka's maxpoll.records, but the underlying mechanics are quite different.
Interesting. It sounds like Kafka gives you more fine-grained control over how consumers behave. Are there any common pitfalls or misunderstandings people have when tuning Kafka consumers?
Absolutely, Sheila. One common mistake is over-optimizing for speed at the expense of responsiveness, or vice versa. For example, setting fetch.min.bytes too high might improve throughput, but could introduce unacceptable delays for some use cases. Another pitfall is not considering the impact of configurations on the entire system. For instance, setting max.poll.records too high might overwhelm downstream systems that process the consumed messages.
Those are great points, Victor. Before we wrap up, could you share some best practices for tuning Kafka consumer performance?
Certainly. Here are a few key tips. Start with the default configurations and benchmark your specific use case. Monitor consumer lag to understand if your consumers are keeping up with producers. Adjust fetch.min.bytes and fetch.max.bytes based on your message sizes and desired responsiveness. Set max.poll.records based on your processing capacity and desired commit frequency. Tune session.timeout.s and heartbeat.interval.ms based on your network conditions and tolerance for rebalances. And finally, consider disabling auto-commit and manually committing offsets for more control over message delivery guarantees.
Thank you, Victor. Those are really helpful tips. Now let's get back to our quiz question. Can you reveal the answer about consumer lag?
Of course, consumer lag is the difference between the last produced message and the last consumed message. It's a crucial metric for measuring consumer performance because it indicates how far behind the consumer is in processing messages. High consumer lag can lead to data processing delays and potential data loss if messages expire before being consumed. Monitoring and minimizing consumer lag is key to ensuring efficient and timely data processing in Kafka.
Excellent explanation, Victor. To summarize today's episode, we've covered key Kafka consumer configurations, including fetch sizes, polling, session timeouts, offset management, and auto-commit settings. We've discussed how these configurations impact performance and compared Kafka's approach to other messaging systems. Remember, tuning Kafka consumers is all about finding the right balance for your specific use case. In our next episode, we'll be diving into handling failures and rebalances in Kafka consumers. Until then, keep those consumers humming. If you've enjoyed this episode, please subscribe to Kafka Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth Kafka knowledge. Thanks for listening.